All right, in module number 4, we're going to go ahead and take a look at some of the common attacks that exist on endpoints. This is going to include things like a buffer overflow attack, malware. Of course, that's a very broad topic. That could include lots and lots of different types of any kind of software that's being installed on the computer that we just don't like, that malicious software. We're going to take a look at reconnaissance attacks. We're going to look at how we gain access and how we gain control of a system. Gaining access through social engineering techniques, gaining access via web-based attacks, what are exploit kits and rootkits. We did talk a little bit about exploit kits in the last section. What is privilege escalation? What is post-exploitation? And what is that post-exploitation phase? You know, what do we do after we've successfully attacked a host, or what does the attacker do, I should say. What is the Angler exploit kit? Again, we talked about that quite extensively actually in module number 3, but we'll talk about it again. And then we'll wrap up this module by doing our summary challenge. And then we're going to start to focus on the Cisco specific technology. All right, so let's go ahead and get started. Obviously, endpoints consist of many, many different components in our enterprise. Obviously, our desktops, mobile devices, laptops, smartphones, printers, but it could also include a lot of other components, especially with the implementation of essentially networking on just about every piece of technology that exists today. The Internet of Things, if you will. So we're going to take a look at, throughout this entire module, various common types of attacks that can happen against these endpoints. Now keep in mind the purpose of this course, and certainly the purpose of this section or this module within this course, is not to go into a significant amount of detail on each of these topics, but we are going to spend some time kind of introducing some of these threat vectors, just so that we can be aware and we can maybe possibly identify some of the Cisco specific tools that we can use for mitigation to potentially reduce our vulnerabilities and reduce our threat footprint, or our threat scope, right? The likelihood, the impact, etc. So we'll start by talking about buffer overflows. So obviously a buffer overflow is a way for us to manipulate a system and basically force that system to do something that we don't want it to do. Buffers themselves are basically just memory storage regions that temporarily hold data while it's being transferred from one location to the other. A buffer overflow, or what is often referred to as simply a buffer overrun, occurs when the volume of the data exceeds the storage capacity of that particular memory buffer. As a result, what's going to happen is that the program attempting to write the data to the buffer overwrites the adjacent memory locations. For example, a buffer for login credentials may be designed to expect a username and a password input of 8 bytes. So if a transaction involves the input of 10 bytes, that would be obviously 2 more bytes than expected, the program may write the excess data past the buffer boundary. Buffer overflows can affect all types of software in all types of systems. And the typical result from these malformed inputs, or failure to allocate enough space for the buffer for that particular capture of data or whatever it might be, results in the system either providing us the ability to execute commands in the system, or even potentially just causing that system to crash. If the transaction does overwrite executable code, we can actually cause a program to behave unpredictably and generate incorrect results. We can cause memory access errors, or we could also cause the system to crash. So what is a buffer overflow attack specifically? Attackers actually exploit buffer overflow issues by overwriting the memory of an application. This actually changes the execution path of the program and triggers a response that damages the files or exposes what's supposed to be confidential or at least private information. All right, so let's say, for example, an attacker introduces extra code, sending new instructions to the application so that we can gain access to a system. Once we gain access to that system, we have the ability of pivoting from that system or potentially escalating our privileges and launching other types of attack. If I know the memory layout of a program, I can intentionally feed input to that buffer, knowing that that buffer cannot store that information, and overwrite areas that hold the executable code, replacing it with our own code. I could overwrite, for example, a pointer. Pointers in programming or in computing terminology is basically an object that points to another area in memory. And we can actually point it to an exploit payload to gain control over that particular program. Now, there are basically two types of buffer overflow attacks. We have stack-based buffer overflows. These are kind of the most common, if you will. These leverage stack memory. That stack memory only exists during the execution time of a particular function of an application. And then we also have heap-based attacks, H-E-A-P. Heap-based attacks are harder to carry out because they actually involve flooding the memory space allocated for a program beyond the memory used for the current runtime operation. All right. Are all programming languages vulnerable? Certainly C and C++ are languages that are highly susceptible to buffer overflow attacks. They don't really have any built-in safeguards against overriding or accessing data in their memory. Mac OS X, Windows, Linux, all use code that was actually written in C and C++. Languages like Perl, Java, JavaScript, C#, they have built-in safety mechanisms that help minimize the likelihood of a buffer overflow. So understanding that this is a relatively common or potentially could be a common problem, how do we prevent against buffer overflows? A developer can actually protect against a buffer overflow vulnerability through different security measures that they incorporate into their code or by using a language specifically designed with that built-in protection. All right. In addition, most modern operating systems do have active runtime protections. There's basically three common active runtime protections that exist. ASLR, which is the address space randomization, randomly moves around the address space locations of the data regions that are being used. So buffer overflow, when we talk about implementing a buffer overflow attack, we need to know the locality of that executable code. Randomizing that address space makes it practically impossible to know the locality of the executable code that we're trying to affect. Data execution prevention is another method. Flags that we can act or flags that we can trigger, we can kind of flag certain areas of memory as non-executable or executable memory. And that's also going to help stop the attack from running code, particularly in the non-executable region. We also have SEHOP. I call it CHOP. Some other folks might call it something different, but it's the Structured Exception Handler Overwrite Protection. This helps stop malicious code from attacking the structured exception handling because it has a built-in system for managing the hardware and the software exceptions. So what do we do if there's an exception to the processing of the data? It's going to prevent an attacker from being able to make use of the SEH overwrite exploitation and that method with these different protections. It's a little bit beyond the scope of this class to get into the specifics of that, but this is another common method. Security measures in code and in your operating system are probably not going to be enough. So we need to be able to identify other methods or techniques to protect our systems in the end. All right. So what are 3 threats to a vulnerable application during a buffer overflow attack? Certainly the corruption of data would absolutely apply in this case, right? Overriding actual real information that might exist outside of the allocated memory for a particular application or the execution of particular application components. We can definitely perform some sort of denial of service by causing an application to crash, and we can also execute malicious code by basically writing that malicious code into areas where execution takes place, replacing other code that normally would be executed as part of the everyday operation of that particular platform. Iframe injection has to do with web browsing, and cross-site scripting has to do with web browsing, and so that's not going to apply in this particular case. Now, the concept of malware, right? Malware, I mean, this topic here is such a vast topic because there are so many different types of malicious software that can be installed on a computer. There are a lot of different objectives of these applications to be able to attack a system and take over a system. So we're not going to spend as much time as we potentially could on this particular topic, but we will introduce some of the basic concepts. And of course, most of you being security professionals, or at least in the security space, probably understand at least on its face what most of this stuff represents. Malware is basically just malicious software. It's basically any software that is installed on a computer or an operating system or some component within the network that isn't supposed to be there. And different types of malware have different intentions, right? It could damage the computer. We could exfiltrate information. It could be something that we're doing to create this zombie computer that's going to be part of a botnet, and we can control that through a CNC machine and whatnot. So any kind of malicious software or unintentional software that's not supposed to be there, really could be considered malware, right? And there's different types, right? We have viruses, we have worms, we have Trojan horses, we have ransomware, spyware, adware, rogue software, wiper software, scareware, and certainly we can talk about all of these different types of malware, right? A computer virus is a program typically that when you execute it, it actually will replicate itself by modifying other computer programs and inserting its own code into that program. If that replication is successful, those areas that get affected are basically identified as infected computers. Now, the difference between a worm and a virus is that computer viruses generally require some sort of host program. The virus writes its own code into that host program. When that program runs, that virus program is executed, causing the infection and then subsequently causing the damage, whatever the intent of that particular virus might be. The worm itself doesn't actually need a host program. It's independent and actually kind of self-contained as a code chunk. So it's not restricted by the host program. It can actually operate independently and carry out its attack independently. All right? And certainly you could go out and you could look at all the different types of viruses. What are the operational components, the parts and the phases of a virus, and so on. The infected targets, is it a resident virus or a non-resident virus? What is a macro virus? What are boot sector viruses, and so on? It's a little bit beyond the scope of this class to get into those particular examples. But there are a couple of things that I do want to mention before we move on to the discussion of worms. The computer virus itself has basically three main parts. It has an infection mechanism, which we call the infection vector. This is how the virus spreads itself and propagates itself. Typically, viruses are going to have some sort of search routine that's going to locate the files or the disks that we're trying to infect. Then it has a trigger. This is called the logic bomb. This is basically the compiled version that is activated anytime within the executable file when the virus is run, that then determines the event or the condition for that payload, that malicious payload, to be activated and delivered to the intended target. It could be a date, it could be a time, it could be the presence or the activation of a particular program. It could be really kind of anything, any kind of telemetry that we can collect from the computer, how much storage space do I have left, and so on. Or it could be just simply that the user has double-clicked a file or launched an application or launched a file, and the virus will execute itself. The payload is perhaps the most important piece, because the payload is the actual body or the data that carries out that malicious purpose for that virus. Payload activity could be noticeable if it's actually being delivered. Depends on what type of virus it is, right? Ransomware typically is more noticeable because of the cryptography function on the computer, but the computer could slow down, it could freeze, applications could crash, so if you see things like this happening on your computer, it is potentially possible that you have a virus. Sometimes viruses are actually non-destructive, but they are distributive. This is what we call a virus hoax. Now, there are some phases to the virus as well. They have a life cycle, and that's part of the biology of the virus, if you will. Basically 4 phases. We have the dormant phase, we have the propagation phase, we have the triggering phase, and then finally we have the execution phase, right? The dormant phase is that idle time. The program has somehow managed to gain access to the computer, but during this stage, the virus is not doing anything. It's not taking any action. Eventually, the virus will be activated based on that logic bomb, and that's the trigger, which then basically puts the ball in motion, if you will, and the virus starts to do whatever it does. Propagation phase, as the name implies, is where the virus is multiplying itself and replicating itself. It's going to place a copy of itself into other programs or into areas of the disk. The copy itself might not look the same. It might be amorphous to the original version of the virus. Viruses will often morph themselves so that they can evade detection techniques and whatnot by antivirus applications that actually do detection based on signatures and whatnot. And then these become essentially clones of that particular virus. The triggering phase is where we move into the activation of the virus itself. This is the point in which the virus performs the function that it was designed for. All right, and again, this could be a logic bomb on the computer itself that identifies when that virus is activated. So a virus could stay dormant for months. I'm not aware of any that have stayed dormant for years, but certainly days, months, weeks, whatever. And then eventually the virus will be activated. All right. The execution phase is the actual work that the virus is supposed to do. This is where the payload is delivered and released. We could be deleting files on a disk. We could be doing some sort of denial of service where we're crashing the system, corrupting files. We could even pop up messages to the screen. So it really depends on what the intent of the virus itself is. That will determine what the overall effect is. Now, the worm, as I mentioned before, is a standalone malware computer program. It replicates itself so that it can spread to other computers as well. And in most cases, the computer worm is actually going to replicate itself by using the network, the underlying infrastructure, to be able to replicate itself to other computers in the system. Now, worms themselves can copy themselves. They don't need host programs. They basically distribute themselves based on the law of exponential growth, meaning that the more computers I can infect, the more likely that worm is going to then self-replicate kind of at an exponential rate, right? The Morris worm, that came out in, I think it was the late 80s, 1988. One of the very first computer worms that actually got distributed over the internet. And it was actually really the first time that a computer malware resulted in a felony conviction under the 1986 law for computer fraud and abuse. Robert Tappan Morris was the one that created this worm. He actually went to MIT and launched the, he was actually a student, a graduate student at Cornell. He went to MIT kind of to throw the authorities off, I guess, if you will, and launched the worm in 1988. And you can go out, there's lots of documentation online about how this particular worm propagated itself and what its overall effect was on the network. All right. Now, there are some worms that could exist for good intent. There are worms that exist for exploits. NIMDA, for example, was the very one of the first major examples of a virus exploit. And there's lots of harm that can come. Worms allow computers to join a botnet. They can be used in ransomware attacks. They can be used to exfiltrate data. I mean, it's really no different than a virus. The only difference is that the worm is kind of self-contained. It doesn't rely on another piece of software to be able to facilitate the propagation and the execution of the payload and so on, going through those different stages, right? A Trojan horse is malware that misleads the user of its true intent, right? We understand the idea of the Trojan horse that led to the fall of the city of Troy and so on. Trojans are typically spread by some form of social engineering, all right? For example, if a user is tricked into executing an attachment within an email, it may appear that it's not suspicious. It could be a bill, or it could be a picture from a loved one or whatever. Anna Kournikova picture, or I love you are good examples. But we click on this fake component, this fake advertisement or fake document or whatever, and then that's how the payload is distributed to the computer. So the idea is that we are essentially tricking the host or the user into thinking that this is a valid piece of software or a valid file or a valid document or a valid link, whatever it might be. All right. Trojans do have a lot of different malicious options as well. A lot of times Trojans will allow that computer to connect to a command and control server and then become part of a botnet and so on. So again, there are many different examples of Trojans that exist, and you can certainly go out and do some research on some of the most common ones and what their overall effect was. Some of the big ones, the Tiny Banker Trojan, Vundu, I think, Flashback. Those are some examples of some ones in the past. All right. So again, I mean, we're hitting really kind of the basics of this stuff, right? We're not really getting into the specific details because it's just such a vast topic, right? And it is again beyond the scope of this class to kind of go into all of those individual details. But they do mention something here which I think is important to understand. What is a APT, right? An Advanced Persistent Threat. An advanced persistent threat is really a broad term that's used to describe an attack campaign where the intruder or the attacker establishes some sort of a long-term presence on the victim network or the victim computer or whoever the victim is, to mine data from that particular computer. The targets of these types of attacks, which are typically high-value targets, large enterprises, government networks, and so on. The idea is that we're probably going to try and steal trade secrets or patents, what we refer to as intellectual property theft. We're going to try and compromise sensitive information, employee and user private data, sabotage critical organizational components or elements, deleting databases or deleting proprietary information, or even just simply to take over the entire function of whatever it is that we're trying to attack. Executing APT assaults require a lot more resources than kind of your standard application attack. So these APTs are typically done by cyber criminals that have a lot of financial backing. They have very sophisticated tools and sophisticated techniques that they use. They could be government funded. Stuxnet was an example of a government funded attack. I don't know that it would necessarily be considered an APT, but it was a government funded attack, as a cyber warfare weapon, right? The difference between an APT attack as opposed to some of these other traditional attacks that we talked about in Module 3 and some of the other ones that we're going to talk about in this module is that the APT is a lot more complex. It's not like a hit and run attack. Once we've infiltrated the system or infiltrated the network, we hide our tracks, we hide our capabilities so that we can get as much information as possible from that particular system. They're also typically manually executed. They're not automated. We have a very specific mark that we're trying to access. We're not indiscriminately launching the attack against whoever happens to go to this website or whoever happens to get this drive-by exploit or whatever. All right. And the idea is that we're trying to do a pretty significant or substantial attack. All right. Remote file inclusion, SQL injection, cross-site scripting. These are the types of attacks that are used by attackers to establish the foothold in that network. We could use Trojans, we could use backdoor shells to expand that foothold and then create that persistence. Remember, we have to hide our tracks. We need to maybe pivot through the network, escalate privileges, and so on. All right. So the first component of an APT, of course, is to infiltrate. All right. Infiltration could come through various different types of attacks that I mentioned. We could do denial of service or distributed denial of service attacks against a target. That could act as kind of a confuser or a redirection, if you will, so that somebody thinks that a certain type of attack is happening over here. Let's focus all of our attention on that attack, while on the other side we're doing our APT. Right? Expansion is the next stage. Once we've established the foothold, we move to broaden our presence within the network. We can move up the organizational hierarchy. We can compromise computers with more access or more sensitive data. But the idea is that we need to now expand our ability to accumulate data by basically compromising multiple systems. All right. Stage 3 would be the extraction of information. That's ultimately typically the goal of an APT, is to extract information. Once enough data has been collected and we extract the information that we need, we might go dormant for a while, or we might even just back out, hide our tracks, and use the same potential attack at a later date when additional information is available. So there are, within the context of infiltration, we could test a target for, some sort of weakness. We can deploy, we can create white noise, we can do our initial infiltration, and so on. Then we want to expand our access, broaden our presence, and then move into the extraction phase. And then finally, cover our tracks, right? We still want to make sure that we're covering our tracks so that the people that may be aware that this information has now been exfiltrated, they may not be aware of the tools or techniques that were used to do it. That's why honey nets and honeypots are very useful, because you can actually identify how some of these tools are being used and the techniques and the methods that are being used in these very, very sophisticated attacks. Traffic monitoring is a good way to kind of protect against this. Implementing web application firewalls, Of course, protecting against things like SQL injection attacks or RFI attacks, application layer attacks, is important as well. We can also look blacklisting and whitelisting components, and then also just simply implement control diversity, right? Access control mechanisms, segmentation of resources, and limiting access to resources in the network. So it's not just one the thing that we can do to protect our network. We want to have a good patching solution for the operating systems, encryption of remote connections, filtering of emails, logging of different security events. It's really kind of a defense in depth type of approach that we need to implement, and that's a very, very important concept. All right, so they talk about that here. I certainly went into it in a lot more detail, but hopefully that's helpful. Let's go ahead and do our review question here. Match the malware type with the particular description. All right, oops, let me delete that there. Self-propagates through the use of networks and vulnerabilities. That would be a worm. Is a hidden malicious functionality or a backdoor within an existing program. Requires human interaction. That would be a virus. Hidden malicious functionality within an existing program. It's not the greatest description of a Trojan, but you know, the idea is that we have this program that we trust, that we think we know what that program is, and then there's a hidden function to it. That by definition is what a Trojan is. All right. Now, the next type of attack that we're going to talk about is a reconnaissance attack. When it comes to different types of attacks that exist in the network or in the information technology space, we have a reconnaissance attack, we have a access attack, and then we have denial of service attacks. All right, we're going to talk about reconnaissance attacks in this particular case. Basically, reconnaissance attacks are general knowledge gathering attacks, right? These attacks can happen in logical and physical methods. Whether the information that's being gathered is done through probing the network or through some sort of social engineering or physical surveillance, the attacks can be preventable, right? But the idea is that this is kind of the initial step that we take. We always talk about in these criminal shows like Law and Order and whatnot. You know, the criminal is not just going to simply go rob a bank without actually doing any type of reconnaissance, being able to identify what's happening in that bank, who's working, what their shifts are, what their rotations are. It's a similar concept when we talk about attacking a network. So we can use tools like Dig, like NSLookup, like Whoas, internet-based tools that allow us to gather public information about the resource and use that information and then compile that information, and with maybe one individual component of that information might not result in any kind of particular attack, but combining a lot of that information together could definitely result in us getting valuable information. Some common examples of reconnaissance attacks include things like packet sniffing, doing a ping sweep, port scanning, phishing, phishing, social engineering, internet information queries like Dig and NSLookup and Whois. And then we can examine the information and the telemetry that we get from this, the data that we get from this, and use that to further identify possible threat vectors, possible vulnerabilities in the target, or vulnerabilities with how they interact, right? When we talk about security controls, we always talk about security controls in three different ways, right? Is it a physical control? Like, is it a barrier, a fence, a gate, a lock, a security guard, a physical camera, alarms, those kinds of things. And we also talk about administrative controls, right? Are the users trained to recognize some of these different types of attacks? Are the users compromisable, right? Do they have gambling debts? Do they have, issues that they have in their private life that could potentially affect how they handle business in their work life, right? So that we can use those individuals in compromised systems by leveraging those weaknesses in those individuals. And then we also have our logical or technical controls, like our firewalls, like our access control lists, our next generation firewalls, etc. So reconnaissance is a way for us to go out and identify those potential weaknesses, those vulnerabilities in the system that we can then further leverage to perpetrate whatever attack we want to perpetrate, right? There's basically two types of reconnaissance that you can do. You can do logical reconnaissance. That's basically anything that's done in the digital spectrum. It doesn't require a human on the other side to complete that type of reconnaissance attack. A ping sweep, a port scan, those are examples of discovering systems, or we're looking for systems on the network. That would be an example of logical reconnaissance. All right, maybe we were trying to identify an IP address of a particular system, or maybe a TCP or UDP port number that system is functioning. We can also do information queries over the internet. Who is queries? All domains are registered to independent companies. They belong to the domain provider somewhere. As a regulation of those, the regulation of those domains have to be done somehow. Patenting a product provides us the ability to identify specific elements of that product. So we can look for information online, even with social media reconnaissance, right? Looking at somebody's social media account, being able to identify maybe where pictures are taken or where fences or barriers might be, because we're able to identify it with the geolocation information or even tags that might be applied to social media posts and so on. Now, physical reconnaissance crosses the lines of what a network administrator has control of. There are elements that will never be protected fully, like cameras, man traps, door locks, guards, but these components do play a role in protecting our assets, protecting individuals, protecting physical assets, protecting, intellectual property, and so on. Bank security, for example, may be limited in the ability to stop a robbery attempt where the security team is prepared for, because they might have weaknesses in their security perimeter, right? Maybe the guard can be compromised. Maybe the systems that are used to protect the locking mechanisms that are used to protect the doors can be compromised somehow, and so on. All right, so the idea of any type of reconnaissance is for us to be able to go out and be able to identify these weaknesses. We can do banner grabbing to identify what types of operating systems are running on a system. We can do that using various tools. There's a website that you can actually go to called SECtools. I think it's a .org or a .com. It could be, I can't remember. I think maybe .com. SEC, make sure you spell it correctly, SECtools.com, and it lists all the different types of tools. And of course, you can also download things like Kali Linux, which kind of categorizes tools into their function, right? Is it an access attack type of tool, or is it a reconnaissance attack type of tool, and so on. All right. If I can do a port scan, or if I can identify hosts on the network, I may be able to identify vulnerabilities that exist in that particular system, and then I can use those vulnerabilities to launch my attack. All right. Now there's passive reconnaissance, and then there's active reconnaissance. And there's some kind of variations on how we define passive versus active. Active means you're gaining access to systems, and you're gaining access to systems in order to not to steal that intellectual property or to damage things, but to gain more knowledge about the other systems you might be trying to attack. Passive reconnaissance would mean that you're not actually breaking into systems. You're using essentially the design of these protocols and applications to be able to identify these systems based on their normal function, their normal operations. All right. Vulnerability scanners, a lot different than, say, a penetration scanner, right? Penetration testing generally means that we're actually launching exploits. We're actually trying to penetrate systems that we've already identified as potentially vulnerable, whereas a vulnerability scanner allows us to identify maybe what some of those systems are and identify those systems and maybe potentially identify the weaknesses in those systems. All right. So which two statements are correct? Security engineers that need to locate vulnerabilities in a managed environment commonly use vulnerability scanners like Nessus and OpenVAS. Yeah, absolutely. I mean, there's a bunch of different scanners that you can use. Nessus is a very popular one, but there are many, many different scanners out there. In fact, again, you just go out to Google and search on common vulnerability scanning applications, and you can see a whole list of them. But yes, we would use those kinds of tools as well. We might use those tools ourselves just to be able to identify potentially what other people might be able to identify with the tools that they might be using. All right. Attackers use vulnerability scanners like Nessus and OpenVAS to locate vulnerabilities. Absolutely. Yeah. I mean, the attackers are going to basically use the same tools that we're going to use. If it's good for them, it's good for us, kind of thing. Now, it may not be these tools specifically, but it's going to be a similar type of tool that's going to be used for this purpose. All right. Let's see. Are safe to experiment with on a production network? Yeah, we don't typically experiment with these tools on a production network. And as far as they should never be used, they should be used for a specific purpose, for assessing the vulnerabilities in our enterprise, right? Educate your employees on how to use these scanners. No, you don't want your employees running around using these scanners on your network. Obviously, that should be limited to the individuals that have the purpose of identifying weaknesses in your systems. All right, which statement or what statement correctly describes a reconnaissance attack? A reconnaissance attack is nothing more than script kiddies playing around with software tools. Absolutely not. Now, certainly script kiddies could do reconnaissance attacks. A script kiddie is basically just an individual that doesn't have any real technical knowledge or expertise necessarily with the tools that they're using. They have a GUI interface and they're basically using YouTube and other resources to identify how to run these tools. It's kind of click A and expect B type of thing, right? But it's not limited to that. A reconnaissance attack is an attempt to gather information about an intended victim before attempting a more intrusive attack. That is exactly what it is. All right. That's by definition what reconnaissance is. And we see this in the military space. We see this in the criminal space for criminals that are, kind of more traditional criminals looking to heist art and heist jewels and so on. And we certainly see it in the technology space. Reconnaissance attacks pose no threat. They do pose a threat. It's not, obviously they pose a threat, but it's not entirely possible to block all types of information gathering techniques. Because of the inherent way that networks work, we have to allow communication between the clients. But we could look for scanning scenarios, right? We can have anomaly detectors that look for a lot of active scans, a lot of TCP send requests being sent from an individual host and so on. So there are ways to identify whether these scans are taking place. How the hosts react to those scans individually, that's a little bit more difficult to manage because you want the hosts to be able to respond to requests. That's by definition what these hosts are supposed to be able to do on the network. All right. Reconnaissance attacks are easy to identify and can be suppressed with minimal effort. I just described that. They're very difficult to identify, especially if they're physical and they're not logical, right? Somebody using social engineering techniques to gather information, that might be very, very difficult to identify, and that has to come from the person that's being socially engineered. Practically, they're the ones that have to be able to identify if somebody is trying to get information or exfiltrate information from them. All right. So as you go through and you discuss cyber attacks and the different phases and the different steps to a cyber attack, There are basically 7 steps that exist, 7 distinct steps that exist in a cyber attack. And one of those steps we've already talked about, which is reconnaissance, right? We need to identify vulnerable targets. We need to explore the best ways to exploit those targets, and so on. And we talked about that aspect earlier in this section here. The second step is weaponization, right? We need to use the information that we gathered in that reconnaissance phase to create the things that we need in order to get into the network. And that's what we're talking about when we talk about gaining access, all right? It could be a spear phishing email. It could be, watering holes or fake web pages. That web page could look identical to, say, a vendor's web page or even a bank's web page. But the sole purpose, of course, is to capture things like usernames and passwords, which would provide us the ability to gain access. Now, our ultimate goal may be to steal information from an endpoint, or to corrupt data on an endpoint, or to, exfiltrate information, if you will. But obviously, in order to be able to do that, we need to be able to gain access to that system. All right. It could be through the acquisition of employee credentials, like I said, through some sort of phishing campaign or drive-by malware that launches some sort of exploit kit on the system, and so on. So gaining access is one thing, but we may be able to get into a system that doesn't provide us the adequate privileges that are necessary in order for us to be able to execute whatever type of attack that we're trying to execute. So we could launch a pivoting attack where we use the relationship that the system that we gain control with has with other systems that might provide us more access, so we can then kind of hop to those systems from the system that we've gained access to. Or we could escalate our privileges, and through escalating our privileges, we're able to get the control that we need. And then step 3 of this cyber attack phase is the delivery. This is where the attack actually starts. Now, again, it could be those phishing emails that we send. It could be the watering hole web pages that get posted to the internet, and so on. But finally, we get to the point of the exploitation, right? Exploitation, where we actually get the names and the passwords. We try them against the email systems or against a VPN concentrator. If we have malware-laced attachments, we can send them so that we can remotely access infected computers. We can actually, facilitate the installation of bot software so that we can, install botnet software on a client so it becomes part of our botnet network. We'll talk about that in a little minute, in a second here, right? So the installation would be step 5, right? We make sure that we, have basically continued access. So we might install, for example, a persistent backdoor, or we might create admin accounts on the network, or disable firewall rules, which is kind of like creating a backdoor, if you will. And then step 6 would be command and control. Now that we have access to the network, we have administrative accounts, all the needed tools are in place. We now have essentially unfettered access to the entire network. And we can impersonate users on the network. We can send emails from employees or the CEO. We are in control of the network, and that's the control component of this. All right. We need to, in step 7, of course, action on our objective, right? Now that we have total control, we can do whatever it is that we were trying to accomplish. So command and control attacks, while they may be focused on an individual host or a group of hosts within the network, could potentially compromise the entire network. Malicious network attacks obviously are commonplace. We see this quite often. Oftentimes they're executed over DNS or accomplished through some sort of command and control function. We start, like I said, by infecting the computer, but that computer might sit behind a firewall. So we might send a phishing email that tricks that user into following a link to a malicious website, or opening an attachment that executes that malicious code. It may be through those security holes that we talked about in a previous section in browser plugins, or through Trojan software, viruses, malware, or whatnot. Once that communication is established, that infected machine, once we have control of that machine, could even send a signal to the attacker's server looking for its instructions. So it's actually now acting as kind of a computer that we control. And this is the beginning of, say, a botnet that we're creating. And again, we'll talk about that more in detail here in a minute. All right. We can actually get that computer to carry out the commands from the attacker's C2 server to install additional software. But the point is that we now have complete control of the victim's computer, and we can, in essence, execute any type of code. That malicious code would typically then spread to more computers, and that's where we start to create this botnet, which is basically just a whole network of infected machines. All right, so in this way, the attacker, who's actually not authorized to access the company's network, gets full control of that network. Ultimately, what's the goal? Data theft, shutting down resources, rebooting devices, launching distributed denial of service attacks, and so on. Now, there are many other tools and techniques that we can use to gain access to credentials that are often necessary. We could use dictionaries and brute force attacks. If we have credentials or hashed credentials, we could use rainbow tables to be able to essentially kind of reverse or discover what a password might be. We could look for weaknesses in the protocols themselves, like a collision, where two different input values might result in the same output hash. And there are ways that we can also protect ourselves against this as well. You know, password lockout policies. If somebody enters the incorrect password multiple times, and so on. And we can also create password entropy, right? Storing histories of those passwords and making sure that we're not using simple variations of the previous password, and so on. Also, changing default credentials. Oftentimes with systems, there are default guest accounts, default administrative accounts, and so on that are installed in those platforms. We need to disable or delete those accounts and ensure that those accounts are not active. This is especially important, by the way, on devices that you may not consider to be devices that would necessarily be something that you would be concerned about, right? Those devices would be IoT devices, your refrigerator or a vacuum cleaner or a smart TV or something like that. Believe it or not, those can be attack vectors in your environment because they do have access to the network. They're not running traditional operating systems, but because of that, they might actually be more vulnerable to different types of attacks, especially pivoting attacks, where you can gain access to those devices that are less hardened and then use that access to be able to gain access to other areas of the network. Once we do gain access, getting control of the endpoint is very, very important. All right, so let's talk more about this concept of a botnet, right? We see kind of a diagram here that describes that. A botnet is, in essence, a group of computers that have been compromised. And it may not be for the purpose specifically of gaining access to information on that particular computer. We may just want to use that computer as a different trajectory or as a different vector for the attack that we're trying to launch. It's very easy, potentially, to identify, a denial of service attack that's coming from the same computer thousands of times, right? If I'm sending a bunch of TCP SYN requests in, say, a TCP SYN flood attack, or if I'm sending a bunch of ICMP echo requests from a single host, it would be very easy to identify that type of attack and then potentially mitigate those damages by simply isolating that host. But if we're sending a bunch of TCP SYN requests from thousands of hosts or even tens of thousands of hosts, or we're sending those ICMP echo requests from those hosts, that's a lot different, right? So we have a master control mechanism that provides direction and control for those zombie computers. the originator of a botnet uses that master control mechanism as a CNC server or a command and control server to control those zombie computers remotely. All right, it could be over the web, it could be through some application on the internet and so on. Now, in order for those computers to participate in the botnet, one thing that has to happen, of course, is they have to have that software installed, and they have to be able to communicate with that CNC machine in order for us to be able to execute commands on that particular device. And that will often happen through the implementation of malware, right? We will install typically Trojan software on that computer, something that looks to be benign and useful in our environment, and then it ends up also including that botnet code, or it could be through the use of a worm or a virus in the system. But the botnet operator has to infect those computers by sending them the malicious bot software. All right, and then that malicious bot software oftentimes is self-propagating, right? It will be malware that's designed to not only stay on that particular host, but then also spread to other hosts within that network or within that domain, so that we can have more and more computers that participate in that bot. The bot itself can activate some sort of keystroke logger, capture passwords, capture packets, capture browser information. We can actually relay messages or emails. We can launch denial of service attacks from those computers, or we can even open up backdoors to those computers. All right. The bots themselves have all the advantages of a worm that we see in the environment, but we also get the benefit of having the actual control so that we can actually launch exploits and facilitate the use of those exploits. All right. So the bot that gets installed on that computer logs into the command and control server, and then it simply waits for the instructions of what it's supposed to do. That's why these are often called zombies, because they don't really act independently. It's a group of kind of a herd mentality, if you will, a group of computers that wait for instructions and then execute whatever instruction it is that they're sent from the command and control server. All right, so in this particular diagram, all those computers with the exclamation point are infected, and they have some sort of back-end communication with the command and control server. The attacker is manipulating the command and control server, and in turn sending instructions over to those zombie computers to perpetrate whatever attack they're trying to perpetrate. All right. What is the difference between brute forcing and password spraying? Now, I actually didn't talk about this in the discussion in this section here, so let me kind of give you a description of what password spraying is. Now, password spraying is actually a type of brute force attack, and the attacker basically uses a single password against specific targeted user accounts before moving on to attempt the next password. So that means that we're not necessarily hitting those password lockout policies over time. For example, there may be a time element to how often a failed login attempt could take place. So we're actually, rather than trying a bunch of random passwords on a single account, we're trying one password on multiple accounts. So it is still technically a brute force attack. It's just a different type of brute force attack. So given that, let's go ahead and take a look at the possible choices here. Brute forcing refers to extracting the AES keys from memory, and password spraying is attempting all possible passwords from a dictionary of common passwords. Brute forcing is guessing passwords as well, but it's typically against one single account. Well, the traditional brute force attack anyway. Brute forcing is calculating the most likely password for a user based on the user's birthday, anniversary, children's birthdays. Password spraying means we try every password in the dictionary. So again, this isn't true. Based on the definition that we stated, this is not true, all right? Brute forcing is coercing users to give us their password, and password spraying refers to gathering credentials through phishing campaigns. Again, not the appropriate definition. Brute forcing is an attempt of every possible password on certain accounts, and password spraying is attempting only a couple of common passwords on every possible account. So that's definitely the definition that would apply. It could be a little bit more specific than that, but that is definitely, not sure why it's not selecting there, that is definitely the correct answer based on the other choices that we have here. So if we look at some of the examples that we see here, calling a user on the phone and claiming to be the IT department, right? We need to reset your password because of some event that occurred. That would be kind of an impersonation type of social engineering attack that also kind of incorporates a level of trust, being that we're calling from the IT department, and also a sense of urgency in that, hey, your security might be compromised, so it's very important that we do whatever we can to protect you, right? The individual user without a badge following the badged user, tailgating. Now that's not directly, I guess, necessarily a social engineering attack. It's just poor training from a user's perspective or from the employee perspective. But it is possible that tailgating could occur because you have befriended somebody and they're less likely to say, you know what, I can't let you in. You need to go ahead and check with the security office rather than some stranger just trying to follow somebody through a secure area. Baiting, right? Leaving a USB key in a parking lot. I mean, if you think about this concept, this baiting concept, and I'll go into some of these others a little bit in more detail, but you know, if you think about this baiting concept, it is probably going to be a pretty effective type of attack. Maybe not predictable as far as the individual that you're targeting, although that is possible. But if you think about it, if you took 100 USB drives or even 20 or 30 USB drives and just dropped them around an airport terminal, randomly at different gates, and left one in the bathroom, whatever, how many of those USB flash drives do you think would end up in a computer? It's highly likely, right, that maybe not all of them, but certainly a significant portion of them would end up in a computer. Fictitious personalities, on social networking, fake Facebook accounts or Facebook accounts from celebrities or whatnot. That's another type of impersonation. Sending an email, enticing the user to click. That's the phishing concept, right? The PayPal scam that we talked about. eBay transaction saying we need to reset your account because there was a compromise or whatever. I mean, there's all types of different social engineering attacks, but it really is just an action in which you're essentially tricking an individual into doing something they normally wouldn't do. And we use this every day in life. It's a really interesting concept. It is definitely human nature to want to be helpful. It is generally human nature to say, you know what, I want to assist. I want to be helpful, and as such, that can result in these issues, right? These social engineering attacks. So a baiting attack, as the name implies, is basically providing some sort of false promise and really kind of piquing on the victim's curiosity, potentially their greed, luring a user into a trap so we can steal their personal information, and dropping a infected flash drive in different areas would be really, really simple. There was a show called Mr. Robot, and they actually used this technique in order to break into a prison computer system. Prisons are notoriously secure, right? Either getting in and getting out, taking stuff in and taking stuff out. But what they did is they put a piece of malware on USB flash drives, and they dropped them in the parking lot where the security guards or the prison guards parked their cars. And sure enough, one of those prison guards grabbed one of those flash drives and walked it through security and plugged it into the computer, and they were able to gain access to that computer. So it is a very, very simple type of attack, right? Oftentimes, if you're doing impersonation, if you're good at it and you're convincing, imagine if you put on a bright yellow vest, We see this on those little, you know, shows and whatnot where they're pranking people. But you put on a hard hat and a yellow vest and grab yourself a clipboard and something on a lanyard, and you start walking around a park and you ask people to leave because you're going to be doing construction. How many of those people think? How many times you think those people are going to actually leave? Probably most of the time, right? As long as you portray or at least act out the role, you know, adequately, right? It's a very, very interesting concept. I think this is probably one of the most interesting aspects of cybercrime is the social engineering aspect. All right. Scareware is another option. They didn't really kind of mention that in this particular case, but maybe it's a false alarm or some sort of fictitious threat, right? The little pop-up that says your computer is infected with malware, and now you have to install this software that actually doesn't do anything, and actually, in fact, it's probably malware itself, and then it infects your computer and so on. That actually happened to my aunt. She installed one of those applications, and of course it says, now you need to call us. We found 25 viruses on your computer. You need to call us. And sure enough, she got connected to a call center, and they were going to charge $25 per virus to remove the viruses that were either false positives or something that they put there in the first place. Pretexting is another concept as well. The attacker obtains information through different lies, right? Basically, it's initiated by the attacker. You know, they're pretending to need sensitive information, you know, to perform some sort of critical task, right? So the first bullet point here could be considered somewhat of a pretexting type of attack, right? We start by building trust with the victim. We impersonate a coworker, some person in authority, some person that you know, works for the government or the IRS or whatever, and you know, they kind of right to know responsibility. And we ask questions that are generally required to confirm the identity of the individual, and then in that way we're gathering that information. You know, and you could do this in stages as well. You know, you might say, you know, call a help desk and say, you know, my wife set up an email account for me, and it's this email, but you know, I don't recall, you know what the password is, and that person might say, you know, in order for us to assist you, we need to know what your address is, right? And of course, you may or may not have any idea, but you could say something like, well, you know, we just recently moved to LA, so I don't know if you have our LA address or if you have the other address. And then maybe the person on the phone says, no, this address is in Texas. So now you have a piece of information that you can use. You can hang up the phone, you can call back, and you can do the same thing. And, you know, over time, you might be able to get more and more information. All right. Now, obviously, it's a lot more difficult. You know, 10 or 15 years ago, the level of security that service providers used and email providers and so on was relatively thin. And it was actually fairly easy to get information. Now everything is done with push notifications and passcodes and passphrases and secret questions, and oftentimes it is some sort of multi-factor verification method, right? You can't really reset your password on your accounts anymore without getting a text message to a phone or some other action. So, which is frankly how it should have been in the first place, right? Because that makes it much, much more difficult. All right, phishing attacks, like I said, we've talked about phishing attacks multiple times. Email or text message campaigns, although text message is often called a smishing attack, SMS phishing. But basically, again, we might be you know, creating this sense of urgency or curiosity or fear, and then you know, somebody clicks on a link, they go to a malicious website, they put in their information and so on. All right, spear phishing, and there's multiple types of phishing attacks, by the way. Spear phishing is kind of more of a targeted version of an attack where I'm actually targeting specific individuals, maybe employees that work in the human resources department or employees that work in the engineering department if I'm trying to steal intellectual property. Whaling attacks, maybe it's an executive or somebody that has a lot of knowledge, those types of things, right? There are many, many other types of social engineering attacks. Now, how do we prevent these social engineering attacks? We need to prevent these social engineering attacks by training our users. That's probably the most important aspect, right? Train the users. Make sure that they're aware of what these con games look like. If you get an email from the IRS with a PDF attachment or an archive attachment, think about it. The IRS is not going to be sending you private tax information through email, right? You just have to use some, common knowledge and common sense. But, oftentimes, the tactics that are used are very, very convincing. And people tend to forget that common knowledge. We could certainly do things like multi-factor authentication, obviously keeping anti-malware and anti-virus software updated so that in the event that an attack is perpetrated, that we're mitigating the potential damages and so on. They talk about the phishing attack here. Like I said, a phishing attack is any type of attack that is directed through email that is spoofing or pretending to be somebody else that they're not. And generally the goal of any phishing attack is to get you to take an action that you normally wouldn't take, right? And we've all seen these. We've gotten the PayPal notifications for a receipt or password reset notifications for eBay or the IRS tax scam emails and so on. And the idea is that basically you're just trying to look official. You're trying to look like it's a legitimate information, even to the point where you're probably even spoofing the website itself when you click on the link, or you're impersonating the website and even impersonating information in the email itself. It is entirely possible, of course, that you could even get some account information, like an email or a phone number or whatnot, and put that into that unsolicited email so it looks like it's even more legitimate. All right. So I talked a little bit about these different phishing types of attacks. Spear phishing, like I said, directed at specific groups of users, not necessarily highly influential users, but users that might be involved in working with the components that I'm trying to gain access to. Whaling would be more of targeting a top executive or somebody that has a more privileged level of access, like the term, the casinos use. Here comes the whale. The whale is the big spender, right? Well, in this case, the whale is the person that has access to really, really valuable information. All right. Farming is another concept. Now, farming is typically an attack that is facilitated by poisoning DNS, right? So redirecting or responding on behalf of a legitimate DNS server with fake DNS information so that we can redirect somebody to a fake website, or poisoning their own DNS information. There's a couple ways you could do that, right? You could modify the local host file on the computer and insert localhost DNS entries so that the DNS resolver just simply uses that localhost information to resolve the destination. You could intercept DNS queries and send DNS replies. You could poison DHCP, right? Put in a rogue DHCP server that assigns legitimate addresses and gateways, but assigns an illegitimate DNS address that would direct all the DNS queries to your fake DNS server. All right. So farming is that kind of concept. Now, there are other types of attacks. For example, here, oops, sorry about that. We see watering hole. A watering hole is an interesting concept because it's another type of social engineering attack in which you are essentially participating in, or at least attacking or manipulating a specific target, knowing that individuals visit that target. Probably the easiest or best example that I can give that would describe this is like a Facebook group or an online forum or a message board or something like that. Now, you may know that, for example, the CEO of a company is a fishing enthusiast, and they participate in this Facebook group, this phishing Facebook group. And so you join that Facebook group, you know, pretending that you're also a phishing enthusiast. And over time, you build a reputation and you build a rapport with that CEO. And, you know, 6 months down the line or whatever, you send the CEO an attachment. And based on that attachment, oops, sorry about that. Computer went to sleep there for some reason. Based on that attachment, guess what happens? Hey, oh, this is Bob. Bob's in that Facebook group. We talk about phishing all the time. I'm going to go ahead and open up this attachment because I trust Bob. Does that make sense? So watering hole is a way for us to, I mean, we could certainly go to a website, you know, that we know that people congregate at and simply put in malicious software. But watering holes are basically places that you can go where you know that the victim is specifically going to be, you know, participating in, or they're going to be, you know, part of that group. Vishing is basically phishing over with voice, collecting personal information over the phone, and that's obviously something that happens quite often as well. Even today, it's still a pretty active way of gathering information, calling somebody and collecting information, right? You know, you might call somebody and say, is this so-and-so? And you say, yeah, this is so-and-so. Well, this is, you know, whoever, and I was in your neighborhood. I saw you had solar. When did you have your solar installed? May I ask, you know, who the installer was, and then you're just kind of gathering information. Who knows what your ultimate goal is? But again, it's just gathering information over the phone. And smishing is the phishing over SMS or texting. All right. So, you know, there are many, many different types of social engineering attacks. But again, it's all about, you know, preying on the human propensity to want to help, right? Or the human propensity to want to be able to participate, if you will. All right. So we see here in this example, a common way of attacking a host is to attack the user on the host, right? Client-side attacks are effective to gaining entry to protected networks. A common example of this would be like, you know, having that fake pop-up that shows up on the computer that says, oh, you're infected, please call the help desk. Now, they don't have direct access to your computer. They don't have the credentials. They don't have the control. The AUC functions are restricting that potential access. And rather than trying to come up with some sophisticated method for gaining access to the computer, they push out some sort of malvertisement or some sort of pop-up that's relatively easy to do that says you're infected, call us. And then as soon as you call them, hey, we need to go ahead and scan your computer. We're going to go ahead and request that you give us control. And you give them control. So they didn't have to go through the whole process of actually breaking into the computer and gaining access to that computer. You basically, you know, fell for their trick. You said, oh, okay, you guys are going to help me out? Great. That was the trick that my aunt fell for. All right. Now, how do watering hole attacks avoid detection by scanning devices? Let's see. By focusing the malware of its campaign so that it is only delivered to visitors from the IP address range of the target organization. Yes. So it's not a blanket attack. We're not just simply blasting this out. It is a targeted attack. And it's based on geolocation. It's based on a group of people that have a common interest, or they actually visit a common location. So that by definition is basically what a watering hole attack is. Now this is a little bit more specific, but it's the same general concept. All right. The other ones wouldn't apply here. Compromising a web server of an innocent bystander so that the malware attack cannot be attributed to the servers owned by the attacker. That would be covering your tracks, right? By compromising DHCP servers of home routers so that the users will be directed to the websites that are compromised by the attacker. That would be a farming attack, and that would be specifically manipulating DNS. By delivering email only to valid email addresses that are targeted from a specific list. so that the volume of traffic stays low. That would be more like a spear phishing campaign, right? Only a group of email users. So in this case, the answer is A. All right. Let's see if we can get that highlighted there. Come on, there we go. Which three social engineering statements are correct? Social engineering largely leverages most people's good nature and desire to help. I mentioned that a couple of different times, right? It is just in our nature, most of us, not everybody, but most of us, it's in our nature to want to be helpful and to try and help people out. Social engineering can be achieved through seemingly normal situations or appearances to obtain access to resources or physical locations otherwise off limits. Yeah, I mean, think about it. You go to a business and there's a receptionist at that business, and that receptionist's job is to make sure that people that are not authorized to go into the facility don't go into the facility. But if you show up in an official uniform and a clipboard and a hard hat and all these other things, a fake badge or fake ID that can't even be verified, and you're convincing enough, most likely they might let you in. You might say you're with the fire department and you need to go ahead and check where all the fire extinguishers are. They might say, well, okay, I'll go ahead and open the door for you. Just let me know when you're done and I'll see you out, right? I mean, that's entirely plausible. It's entirely plausible. It depends on the environment, of course. Obviously certain environments have much more strict regulations versus other environments, but it is entirely possible. All right. Social engineering is easy to spot and should be called out immediately in front of everyone to unveil the fraud. First of all, it's not easy to spot. If it was easy to spot, in a lot of cases, it just wouldn't be that successful. I mean, certainly some types of social engineering techniques are easy to spot, but others are very, very good. Scam artists are scam artists for a reason. They do it because it's easy, or it's not easy, but it's successful. So if you have a really good con artist, they're going to be able to trick you. Okay. Phishing is a social engineering technique. Yes, it is. Although it's more technical, right? It's the content of the email, right? We're still getting somebody to technically click a link and whatnot, but it's the content and the wording and how the email is constructed and how well it's crafted. And that's what plays on the mind part, because it looks legitimate, it smells legitimate, it must be legitimate. Okay? Social engineering is not a security threat. It is absolutely a security threat. No doubt about that. All right. All right. So exploit kits or exploit packs are basically these automated programs that are used by attackers to exploit known vulnerabilities in systems or in applications. They can actually be used to secretly launch attacks while somebody might be browsing the internet or doing other what would normally be considered kind of relatively benign things. But the goal is to download and execute some sort of malware on that particular host. Because these exploit kits work in the background, it can actually be really difficult to know whether you're under some sort of attack. Obviously, there are measures, and we've been talking about a lot of these different measures throughout this course, and we'll continue to do so as we continue through the course to kind of avoid or at least mitigate the possible damages from these attacks. But an exploit kit in and of itself is really just a package that is used by the attacker to deliver that malware or that malicious software. All right. And I'll actually kind of, even though it's not really part of this specific discussion, I'll actually go into really the kind of the phases of an exploit and how the details of how an attack is executed. But the gist of the entire thing is that the victim visits some sort of compromised website, and if they have certain vulnerabilities within the software on their computer, that particular exploit that takes advantage of those vulnerabilities can be sorry about that. That can be used to carry out those particular exploits. As a result, the malware is going to get downloaded and executed on the victim's device. All right. So software vulnerabilities, of course, are the cornerstone to any type of exploit being successful. And a software vulnerability, by definition, is really just an error or a bug in the code that enables the attacker to get into an application in some way. And in this particular case, the way we're talking about is an exploit by running an unauthorized task. The known vulnerabilities are named in a reference document or reference location called the CVE, or what we call the Common Vulnerabilities and Exposure Reference. So there are several thousands of tens of thousands possibly of known exploits in the CVE that are specific to different types of browsers and different types of applications. Common targets for exploits are basically popular software that is known to have lots of vulnerabilities. Things like Adobe Flash, Oracle Java, Internet Explorer, and so on. And in essence, the more popular the application is, the higher chance that the attacker has of attracting some sort of victim, because there's just simply more and more hosts to possibly infect. This is also where exploit kits come in especially handy for the attackers that are trying to do these attacks. Exploit kits actually target multiple vulnerabilities at the same time, and they try to compromise everything that the attacker is going to need to carry out that particular attack. If one of those exploits doesn't work, or if it doesn't result in whatever the desired result is, another one might be. So increasing this would, of course, increase the cyber criminal's chance of executing a successful attack and accomplishing their overall goal. All right. Now, these particular types of exploits, and a lot of different types of exploits, do come in as pre-built kits, which also makes them very easy to implement, especially if the cyber criminals or the attackers really don't have a lot of high skill or programming skills or technical knowledge. They're more like script kiddies, if you will. They can still execute these exploits. All right. Now, there are several stages necessary for an exploit to be successful. Number one, of course, you have to establish contact with that host environment through some sort of landing page, and that's probably one of the easiest aspects of the exploit. We need to redirect to an alternative landing page and detect the vulnerabilities in the host. This is where that drive-by download concept comes in that we talked about previously. But we need to be able to identify the vulnerabilities in the host that we can actually exploit, and then we carry out that exploit. We spread the malware. We infect that host environment by executing the malware, and then hopefully we have the ability at this point now to start replicating that and infecting more and more computers and so on. All right, so there, certainly there are many different types of exploits that exist, and we've talked about a few of these, but overall, those are the general concepts, right? So the first stage, like I said, is to establish contact. Again, we can maybe send somebody to a landing page of a website that we've actually compromised, or we can encourage somebody to visit a site through some sort of phishing attack, or sending an email link or a pop-up or some sort of malicious advertisement or malvertisement. But once that victim clicks that link to enter that site, that initial contact has been established. Now, there may be, in a lot of cases, or even at least in some cases, users that do this that don't meet the criteria. Maybe they're in the wrong location. Maybe these users are protected, or they don't necessarily have the vulnerabilities that we're looking for. And at that point, that particular attack would probably stop because those users are no longer, well, we wouldn't be wasting our time because we know that the attack's not going to be successful. All right. The second stage I mentioned is the redirect. Any victims that we've identified that are potential targets, they're going to get redirected to an alternative landing page, which is no longer the real website that they initially intended to go to. And then the code that's embedded into that landing page determines if the victim's device has vulnerabilities based on browser-based applications or browser-based plugins that correspond to the exploits that we have within the exploit kit. Now, again, if we don't find any vulnerabilities or no vulnerabilities are detected, then that attack stops. But if a vulnerability is found, we'll move on to the next stage, which is the exploit stage. Now, the reason for requiring a vulnerability is that the exploit kit itself needs to run malware on that host environment, on the victim's computer. The application that is vulnerable is used to download that malware. So that's a very, very important concept. The way that the exploit is carried out depends on the application. As an example, if a web browser itself becomes the target, the exploit will be in the form of maybe some sort of code that's embedded within a web page. Or it's maybe a commonly targeted application like Microsoft Silverlight, where the exploit file is directed towards that particular application. The term itself, exploit kit, means that there are multiple exploits that are bundled into one package, which means that we're going to be able to target multiple vulnerabilities. And that's going to make it a lot easier for execution and provide an increased chance of success for whatever our overall objective is. Phase number 4, of course, infect the computer. Once the exploitation has been deployed, the malware gets executed on the victim's computer. As far as what the effect of the malware is, there are lots and lots of different scenarios, right? We did talk about some of the possible effects of infecting a computer with malware. Some of it's, truly malicious and has, high lofty goals of stealing information or exfiltrating information or installing a keylogger or capturing credentials and so on. And some are just plain annoying. But the idea is that that malware gets deployed. Ransomware, for example, is definitely something that we would be concerned with. A popular use for exploit kits is to execute things like cryptocurrency mining software. So we're going to actually hijack the computer's resources and use them for mining things like Bitcoin or other cryptocurrencies without the user's permission. Now, certainly on one computer, that's not going to be a big deal. But if we can do that on thousands of computers or potentially tens of thousands of computers, that changes the game completely. All right. Now, there are security patches that can be deployed by software developers, and each exploit will have kind of a limited lifespan based on that. But kit developers are constantly coming up with updates of their own, so we get new versions of these kits and new exploits against new vulnerabilities, and some kits actually have been around for quite some time. All right. There are some examples. RIG, that kind of came out in 2018, and it also had several different ways of delivering or distributing those payloads, and it was used primarily for things like coin miners or banking trojans, ransomware, and so on. As far as the scope, Grandsoft and Magnitude and RIG was by far the most active exploit. Grandsoft was another one that's also kind of came out in 2018, and that was primarily used for distributing ransomware or Trojans. Magnitude, another one that targeted specifically Asian countries to deliver specific payloads. It's been around for a long time, nuclear, and so on. All right, the exploits are very will have a great deal of success because they do take advantage of a lot of zero-day or day zero vulnerabilities that might exist in applications and in systems. So how do we protect against these exploit kits? We need to keep our software up to date. Don't click any of those spammy looking links that you might see. Avoid ads and pop-ups. And of course you want to use antivirus with the latest antivirus definitions. Now, along the same lines, we also have these things called rootkits. Rootkits is malware. I mean, it's another form of malware, but it's designed to provide a continued or sustained privileged access to a computer while hiding its presence within that computer system. The term rootkit itself is actually connected to the two words that make, kind of join it together, or at least are joined together to make the the word, right? The root and the kit. Originally, rootkits were actually a collection of tools that were enabled at the administrator level, privilege level, for a computer or a network. And the root function meant that you had kind of admin access, if you will. And this was typically something that we would see in a Unix system or a Linux system. The term kit itself refers to the software components that that implement that particular tool. All right. Nowadays, though, we tend to look at rootkits and associate them with malware like Trojans or worms or viruses that conceal their existence from the user and other system processes, so they're extremely difficult to get rid of, right? And the idea here is to maintain control. We talked about access and control in one of our previous sections. A rootkit is designed to maintain control. We want to maintain command and control over a computer without the user knowing it. And once the rootkit's been installed, the controller of that rootkit has the ability to remotely execute files, to change system configurations on that host machine, and the rootkit itself can actually get access to log files and spy on even what's going on that computer itself. Now, a lot of people will just simply define a rootkit as a general concept, right? It's just basically a toolbox in the malware world. They install themselves as part of some other download, like a backdoor or a worm, and then they take steps. And this is the biggest part of this, right? They take steps to prevent the owner from detecting the presence on the system. The idea is that we maintain that persistence. The other aspect of a rootkit is that it almost always operates near or within the kernel of the OS, which means it has very low-level access to instructions to initiate commands on that particular computer. Hackers have included in again, sorry about that. My Alexa is named Computer, and every time I say computer, she decides to speak, so I put her on mute. All right. So where was I? The advancement of these rootkits has actually now extended into the Internet of Things, right? Utilizing things like smart TVs and other smart appliances or smart devices to establish these communication channels as well. I mean, anything really that has an operating system is a target for the rootkit. And it could be your thermostat or it could be your fridge. Now, the rootkits themselves do provide functionality for both security and utilities to the end users. There are several rootkits that we can use on a computer to monitor the capabilities of those computers and so on. But again, anything that can be used for good can typically be used for bad as well. All right. And there have been many rootkits over the years. Stuxnet was a very, very well documented one. Lion, BMG copy protection, NT rootkit, and so on. For the most part, rootkits are really not being developed as much as they were in the past, but it is still something to be concerned with. All right. Now, regarding exploit kits, which option explains what a shadow domain is? Now, they did mention shadow domain up here in the beginning of our discussion here, but I didn't actually talk about that. So let's talk a little bit about what a shadow domain is, and then we'll get into the answering the question. Now, shadow domains themselves are when different domains are actually used to create various URLs, which then redirect users to the real target website on the primary domain. These shadow domains usually have lots of pages that are optimized with specific search phrases or keywords. Shadow domains can actually be used to fabricate, say, false rankings within a search engine result. It's clearly not something that's generally recommended, but it is one of the uses. The pages themselves are not intended for actually viewing by normal users, and they're somewhat cloaked, if you will, from human viewing. And they're read basically by redirecting users transparently to that real website. The pages on the shadow domains do not have to be user-friendly pages because they're actually not intended to be viewed by you as the user. So they have extremely optimized content that is actually specifically designed to get the best results from those search engine crawlers, and then users are automatically redirected immediately from those shadow domains to a more user-friendly website on the primary domain. All right. Now, this sort of technique is kind of disapproved of by most of your search engine companies, and it is possible that you could actually lose access to the primary domain and the shadow domain position within that search engine once they've discovered that these are being used. So with that brief description, let's take a look at the question one more time. Regarding exploit kits, which option explains what a shadow domain is? Is it a second level domain that is registered by a malicious person using compromised domain registration information from a legitimate site? Well, in the context of an exploit, that actually could be very true. I mean, I describe shadow domains in kind of a less nefarious purpose, right? You know, being able to just kind of optimize search engine results and so on. But I mean, the overall concept is still the same. We are creating a second level domain that is registered maliciously so that we can then spoof a primary domain or, you know, trick individuals into thinking that they're accessing a primary domain. So the rest of the answers wouldn't be correct here. The series of redirects that a web browser goes through when a web page is unavailable, that's the HTTP 302 process that we talked about. Websites set up by companies' information security teams to act as honeypots doesn't even fall within the scope of the description. Domains that are registered with dynamic DNS or fast flux DNS services to keep the domain and IP addresses frequently rotating. No, we could potentially be creating secondary domains, but we're not rotating the domains. The goal is to simply point to the primary domain. So in this case, the answer would be A. So the next concept we talk about in the realm of endpoint attacks is privilege escalation. The name really kind of personifies, if you will, what we're trying to talk about here, right? We've been able to get access to a system illegally or through various means, but unfortunately, the system that we've gotten access to doesn't really provide us any true ability to be able to launch further attacks or to install software or to install malware or to spread malware or viruses and so on. And oftentimes it is simply restricted based on the credentials that we're using to gain access to that particular system. So a privilege escalation attack is really simply a matter of us finding some way to be able to escalate our privileges to an administrative level or at least some other advanced level to provide us the necessary means to be able to further launch our attack. All right. And they do mention a couple of different mechanisms here to escalate your privileges. An attacker may identify a stored location of passwords and on the computer that they were able to gain access to. And now we can use that information to identify more privileged accounts, right? If I have poor password enforcement, I can then further use that information to guess what those passwords are through some sort of dictionary attack or some sort of brute force attack. We can also rely on the user to provide the credentials that are needed. Through some sort of social engineering type of process, I can actually capture those credentials by tricking the individual into providing those credentials in some form or fashion. We could use a pass the hash. Sorry about that. We could use a pass the hash tool and use that to move laterally throughout the network. Now, in this type of attack, I'll go into this one a little bit more detail because it's not as easily understood as the rest. But basically, in this is a technique where the attacker captures the password hash as opposed to the password characters themselves, and then simply takes that password hash and passes it through for authentication and potentially to get lateral access to other systems within the network. So if I pass the hash, I may be able to actually authenticate with that hash because the idea might be that Well, if you know the hash, you must know the password, and we can move laterally through the network that way, or we can gain access to a system that way as well. These types of attacks could occur in any kind of platform, but they are most prevalent in Windows systems. Single sign-on exploits or NT LAN manager exploits, Kerberos exploits, and so on are pretty popular with those platforms. So that's another way that we could potentially do privilege escalation by simply capturing hashes and doing a pass the hash attack. We could also extract credentials from memory if we don't have any kind of data in motion protection for that information. And then we could use other sophisticated tools as well. And again, this is the intent of this course is not to get into the specific details of every single one of these exploits, but at least to gain some basic understanding or knowledge of what these exploits are in general and what their potential damage could be. How can an organization protect against a privilege escalation attack? Well, if you think about it, we are talking about, in most of these cases, dealing with credentials. So anything that has to deal with ensuring that we have a better way of authenticating or a more secure way of authenticating or a more complex or, well, I wouldn't say complex, but a more secure approach to password management certainly would provide some mitigation techniques. Multi-factor authentication could be one of those things as well. All right, so let's see here. It says use a common password for multiple accounts. No, that's the opposite. We would never use the same password for multiple accounts. Not only does that eliminate the ability to be able to identify in essence, the non-repudiation of origin. If one account gets compromised, other accounts could potentially be compromised as well. Exercise a strong password policy that includes the requirement of unique passwords for multiple accounts. Absolutely. Strong password policy would definitely help. It's not certainly the only thing that we're going to do. We could also implement multi-factor authentication and other methods for securing authentication, but having a strong password policy should be the foundation of your overall authentication security architecture. Assign new passwords to employees every 30 days. I mean, that could certainly be part of a policy. You know, you have password retention requirements and you have, lifetimes for those passwords, whether it's 30 days or 15 days or 60 days or whatever it might be, will depend a lot on, how strong the passwords are in the first place. What type of work factor is incorporated into the strength of our passwords. So I would say assigning passwords to employees every 30 days, might help, but it's only one small facet of everything that we try to do with a secure password policy or a strong password policy. Use open authentication on your wireless network, meaning no authentication. Certainly not, right? That's not something that we would want to do in any event, right? But it definitely wouldn't help mitigate this particular issue. All right. So after your exploitation phase is complete, the goal is to kind of document the methods that you use to gain access to the organization's valuable information. Or it could be from the victim's standpoint to use the lessons learned type of scenario to identify, how the attack was successful and how we could potentially mitigate that type of attack in the future. But as a penetration tester, if you're doing some vulnerability scanning and penetration testing, you should be able to determine the value of the compromised systems and any value associated with that sensitive data that gets captured. Some pen testers are unable to essentially quantify the impact of accessing data, or they're unable to provide recommendations on how to remediate those vulnerabilities within the environment. So make sure you ask to see sanitized penetration testing reports that clearly show recommendations for fixing those security holes and vulnerabilities. That is, of course, to say that you are talking about this type of post-exploitation as a result of some pre-planned or internally approved vulnerability testing or penetration testing. Of course, it could also apply to the individuals that that are trying to actually steal or capture information, right? They also want to do some sort of post-exploitation because they want to be able to identify potentially additional vulnerabilities or the same types of vulnerabilities that they can take advantage of to get into the system. All right, so we can use tools like PowerShell. We'll talk about that in a little bit. We can use Mimikatz on these compromised machines to actually either elevate our privileges or to even get a larger foothold on that computer. All right, we'll talk about some of these other tools available as well. Now, from the perspective of an attack, right, post-exploitation basically means the phases of operation once the victim system has been compromised by the attacker. The value of the compromised system is going to be determined by the value of the actual data that's stored on that system and how an attacker may make use of that for malicious purposes. So the concept of post-exploitation has kind of come from this fact only as to how you can use that victim's compromised system information, or you can use the data that was captured as well. This phase actually deals with collecting the sensitive information, documenting the information that you've received, and having an idea of the configuration settings, the network interfaces, the other communication channels that are available, and these could potentially be used to maintain persistent access to the system based on whatever the attacker's needs are, right? So, we do talk about the various phases of post-exploitation. One would be understanding the victim itself. Privilege escalation would be a component as well. Cleaning up your tracks and staying undetected would be important, especially if you wanted to utilize the same techniques or the same methods later on. Collecting system information and data, setting up backdooring and rootkits, or pivoting to penetrate other internal resources from that compromised system. So there are many benefits, of course, to this post-exploitation phase. All right, we want to determine what is the information on that machine that we're on. What is the context that the machine is operating at, and what are the processes and so on. We see a list of some of the initial commands that are often run by an attacker who does get access to the machine, and then based on that, they can use the built-in tools on that operating system then to do some of the things that we just talked about. Who am I shows the user account and domain name information for that particular platform. IPconfig, of course, is going to give you all of your IP addressing information. Netstat-ANOEP, all the active, listening, and closed network connections. Of course, those are just switches that you can use to be able to identify specific details, but you can use other switches with Netstat as well. QUser will list all the users who are logged into the system. Task list would also show us all of the processes that are running on that particular system. Schedule tasks will allow us to see, or to set tasks to run on the system at a certain time interval. SC lists all the services that are running in NetStart. These are just some examples, right? But there are many other tools you could use. Anything that's basically going to give you information about the system. Anything that's going to give you information about that system that you can use in the future, or even at that point to escalate your privileges or to pivot to another machine, or just to provide you some sort of advantage in your goal to continue the penetration and continue the attack. Additional post-exploitation events would be to find potentially other systems that are weak, and we can actually use this system now to do vulnerability scans on the rest of the network, which may report additional information that we didn't see previously because we are now a member of that domain or a member of that network, and we might be able to get additional information. PowerShell, very powerful scripting language that's built into Windows. We can use PowerShell to do all kinds of things. We can run PowerShell from memory, meaning that we don't actually have to write any data to disks. We can run it on a remote computer. There are many, many different PowerShell scripts that can be run. The thing about PowerShell is that, of course, it is going to be potentially somewhat limited based on the current user's privileges on that local machine. But assuming that there are at least some privileges available, we could use PowerShell to do quite a few things. A little bit beyond the scope of this class to get into the details of PowerShell, but it is definitely a very useful tool, a very powerful tool that we can use in a platform if we do have those capabilities. All right, if we do have those privileges, I should say. Metasploit is a penetration testing framework that makes hacking somewhat simple, right? It's basically an essential tool for many hackers and even people that are trying to develop defenses against different types of attacks. We can point Metasploit at the target, and we can actually pick a particular exploit, what payload to drop, and we simply hit enter, and that's that. Well, it's not quite as simple as that. We need to understand, of course, what types of exploits exist within Metasploit. There are other integrations that we can use as well, like Nmap, SNMP scanning, Windows patch enumeration, and so on. There are even bridges into Nessus and Tenable's vulnerability scanner as well. But pretty much every single reconnaissance tool you can think of integrates with Metasploit. And that's why we tend to talk about this one quite a bit. All right. Once we've identified a weakness in a system, we can hunt through Metasploit's pre-configured extensible database for an exploit that will actually crack open that hole, if you will, and then facilitate the attack. There are many resources online on how to learn how to use Metasploit and what kinds of things Metasploit provides us. Again, a little bit beyond the scope of this particular class. All right. Which function is performed by an attacker running who am I from the command shell? It learns which user account that they are running under and the domain that it is running under. That's exactly what who am I does. It tells me everything I need to know about the current user on that particular system, which can provide some additional valuable information. It does not determine the registrant that a domain web service is running under. That would be a whois lookup online. It doesn't map IP addresses back to domain names on the network. That would be a NS lookup, mapping, or a reverse NS lookup, if you will, mapping IP addresses back to a domain name, depending on what you're putting in first, of course. Lists all the users who are logged into a particular machine. That was the QUser function that we saw previously. All right, we got one more section here, and then we'll wrap up our lesson. So let's talk a little bit about one of probably the most popular exploit kits that have existed, called the Angler exploit kit. It was probably around 2013. There was an exploit called BHE-Key, the Black Hole Exploit Kit. And it quickly disappeared after they arrested the author, which his name was Ponch, I believe it was. I always remember that because of chips. But so that exploit kind of disappeared. But in March of around 2015, there was a book that was published, or a report that was published, called The Evolution of Exploit Kits. And it noted basically in 2013 that there was this kind of new exploit kit that existed called Angler. And it really kind of blew up in the world of cybercrime and cyber attacks. And it quickly emerged and also quickly died. By the end of 2014, though, it had pretty much become the number 2 exploit kit around the globe. Sweet Orange was probably the most popular at that time. And the name is kind of interesting because if you can picture an anglerfish, that's that fish that has kind of this little dangly, glowing bulb on its head. That would attract other fish thinking that it was food. And of course, if they got close enough, to try and eat that little dangly glowing ball of fake food, then the anglerfish would go ahead and chomp down and have a nice lunch. But why did Angler stand out among all of the other exploit kits that existed? It, in fact, has gone down pretty much in history as one of the most notorious exploit kits that were used in cyber attacks. Even though it didn't last very long, it gained a lot of traction because it had a lot of special characteristics. It spread ransomware and used malvertising and even hacktivism campaigns to actually spread. It was also the second most used exploit kit and was responsible for about, I don't know, maybe up to 20% of infections. Nuclear was one of the top kits at the time, generating about 22 to 23% of those infections. And it's still around, and it's still used quite a bit. There was, of course, a reason why Angler ranked so high with the cyber criminals. And there are some basic functions of what that exploit kit can do. It can be easily used by attackers, number one, who really don't have a lot of deep technical knowledge. All right, if you're not an IT or you're not a hacker, you're not a programmer, the exploit kit itself had a very user-friendly interface, and that would enable the attacker to track the evolution of the malware campaign, adjust the settings for more effective results, and so on. It's also sold in cyber criminal circles, right? Cybercrime as a service has been around forever. And exploit kits like Angler were sold in cyber criminal services and circles for profit, right? And it actually had a pretty good price, which is another reason that it became very popular. It is also a very versatile exploit kit. You could actually utilize it to install malware. In the financial sector, it was Tinba and Voltrak. Ransomware, CryptoWall, and Torrent Locker. You could also use it to collect confidential information like usernames and passwords and credit card information, or you could tie the infected system into a botnet, creating that zombie army, if you will, of computers to deliver additional attacks. All right. Now, the primary focus of Angler was to focus on the vulnerabilities of outdated software. And this is a huge reason, again, why Angler was so successful installing malware on PCs. How many times have you gone through and ignored an update from one of your applications? Angler takes advantage of all those security holes in the systems based on that. And it integrates new vulnerabilities very, very quickly. All right, because of its popularity, because the developers were able to add exploits for those vulnerabilities very quickly, zero-day vulnerabilities hit the market, and Angler was kind of one of those very first exploit kits to actually integrate those vulnerabilities, especially if you were talking about things like Adobe Flash. All right. It also tries to evade detection during each stage of the infection. Innovation was really the key to the success of Angler. The creators that created it took the development of that application very seriously because they constantly adapted their tactics to evade being detected by security products like antivirus products and so on. It could also deliver these invisible malware infections, what we referred to in one of our previous discussions as a drive-by attack. It can also deliver fileless infections, so not a single file actually needs to be downloaded by the attacker to the PC. It could use encrypted payloads and many other different tactics. Its distribution tactics also made it very, very difficult to block. All right. They look for web servers that they can compromise, the attackers. They hack into those websites that are hosted on those servers. Once they're in control of those servers, they create a massive amount of subdomains, those shadow domains, if you will, loaded with Angler. They send the victim through spam campaigns or malvertising campaigns to those subdomains where they initially get infected with Angler, and then they can continue to consolidate that infrastructure as well. All right. It also used things like hacked credentials from data breaches to spread further. It was a very believable exploit as well. It had very well-built landing pages to deliver the exploit. It was also known for being effective malware for whatever infection vector you were looking at. So it had a very high conversion rate, if you will. All right, so how does Angler spread? Well, there are three major tactics that the cyber criminals would use: malvertising, malicious iframes, or malicious code injection. All right, so let's take a look at that Angler chain of events. We have that listed right here. The victim browses to a compromised legitimate website. That compromised legitimate website contains malicious obfuscated, meaning hidden, script or an iframe to redirect the victim to the rapidly changing Angler landing page that actually contained the exploit. The URL structure of the Angler landing page even changed frequently to avoid detections. There could also be multiple stages of web redirections. So before you actually get sent to the landing page that had the Angler software, you might browse through a couple of legitimate websites, a couple of malvertising websites, and so on, eventually getting to the site that's infected. We also used these things called gates. We talked about gates a little bit earlier in one of our earlier discussions. Then the Angler exploit kit scans the victim's computer, looks for vulnerable software vulnerabilities, and then it delivers the exploit based on those vulnerabilities. After compromising the computer, it will then go in and actually deliver the payload, the malware, and then that malware would do whatever it was programmed to do. All right. The malware payloads that ended up getting delivered by the exploit kits were typically ransomware, like I said, but it didn't have to be ransomware. It could have been other types of malicious software, joining the computer to a botnet, communicating to a CNC computer, and so on. Here's an example of one of those reports that you might get. My Alexa again, sorry about that. So CryptoWall here was saying, okay, we've encrypted your data. And by the way, since we've encrypted your data, you need to now pay us, and then we'll send you the private key so that you can do the decryption. Typical ransomware type of attack. All right. Angler was one of really most, like I said, one of the most prolific and most sophisticated Angler kits that existed. The interesting concept about Angler is that most of the compromised servers were actually WordPress-based servers. The Cisco security research team, that Talos intelligence group that we've talked about many times and will continue to talk about throughout this course, actually noted that the popular infected websites redirecting users to the Angler exploit were using malicious advertising, included things like major news, real estate, popular culture sites, and so on. So it was a very, very believable, very believable type of redirection, believable type of malvertising, and so on. All right. Cisco published some other characteristics as well. They were able to find about 15,000 unique sites pushing people into the Angler exploit. 99.8% of those sites were used less than 10 times. So that was very, very effective. All right. There were some interesting facts that Talos discovered as well about the Angler backend infrastructure. Angler wasn't simply a single web application or just a single physical server. The actual Angler architecture included different components that both complemented each other and provided additional redundancy. We have a picture of that right here. All right. So we used proxy servers, we used exploit servers. The proxy servers are the ones that would actually do that interaction with the victim's computer. And then the exploit servers contain the actual exploit code. Those servers are the ones that were actually compromising that victim's computer and through the use of those proxy servers. So the exploit servers delivered the exploit code to the victim's computer through those proxy servers themselves. That basically provided an additional layer of protection. So if you took down the proxy server, it doesn't actually affect the ability to deliver that exploit kit at another time if you simply brought up another proxy. All right. It also allowed single exploit kit servers to provide data to multiple proxies, and then based on that, we were able to more effectively deliver the attacks. All right. So if you look here at the statistics, it says here that during a single day of activity, which is the average life of an Angular proxy server, it served exploits to about 9,000 unique IP addresses. And about 40% of the users that were being served the exploits were actually compromised. That is a really significant number, very significant number. That means that about 3,500 or 3,600 users were compromised by a single proxy server. And if we had the average proxy server that compromised 3,600 users, and there were 147 or 150 different proxy servers, you're talking about compromising about, over what, 500,000 victims or 500,000 computers over the course of a single month. All right. So it was just a really, really effective exploit. Why would an attacker use a proxy server in front of the exploit server? To protect the identity of the exploit server and to make it harder to track. That sounds about right. To be able to infect more machines than a single server could? Nope, because those proxies were acting on behalf of the exploit server. They didn't actually have the malware. To reduce bandwidth used by the attack infrastructure, no, that would be load balancers and whatnot. Redundancy if there was a failure of the exploit server. No, the way we described it is that proxies would be kind of that front end, that system that would kind of introduce you to where the exploits were stored, by therefore protecting. It's kind of like in the criminal organization, you got the people at the low end of the totem pole that are actually committing the crime, and the people at the high end of the totem pole are protected because if the criminal's caught, well, they're the ones that go to jail, right? Same kind of concept in this particular case. Okay? All right, what is the main cause of a successful buffer overflow attack? Careless users violating acceptable use policies. No, that would be an issue with people performing, things incorrectly. Not really a technical issue, just somebody's just not doing what they're supposed to be doing. Poorly written application code that does not validate the input data size. Absolutely, that is what by definition, a buffer overflow attack is. It takes advantage of that poorly written code so that we can write adjacent spots of memory and cause harm. Intentional installation of illegitimate software. I don't know, that might be kind of like an inside facilitated type of an attack. Bad luck of the user who falls victim to such an attack. Well, that would be bad luck, but that's definitely not a technical description, so that wouldn't apply. The structure of an APT attack does not follow a blueprint, but there are common methodologies to the attack. Match the attack steps to their description. All right, well, these are listed in order, I can already tell. The initial compromise would be the first thing that would happen. Then we would try to escalate our privileges. Then we would do internal reconnaissance. And then we would do lateral propagation, compromising other systems to track towards our goal. The end goal of the attacker could be to exfiltrate sensitive information, and the mission is complete. So even though the numbers aren't right on the right side, the order of the descriptions are exactly in the order they should be. Reconnaissance could be something that you look at in the beginning as well, but in this case, we are talking about an advanced persistent threat, meaning that we've already attacked a host, and now we're trying to find a way of maintaining that access or even escalating those privileges. What type of data can be learned about a server by performing a basic port scan with Nmap? A list of patches that are missing from applications. Port scans show us ports. That's why it's called a port scan. So that would not show us anything about the software updates. Misconfiguration of web applications allowing command injection, negative. A list of all the open ports and services that are running on that computer. Absolutely. We're looking for open ports. Now that's done typically by using a TCP SYN attack or using some sort of TCP three-way handshake. And if a client is listening on a particular port, they're going to try to continue processing that handshake. And through that process, we are able to identify if there is an open port. A list of all the systems that the server is communicating with, that would be netstat. A list of all the users who are logged onto the server. No, that would not be it. All right. That would be the queue user that we talked about previously. What is the most difficult stage of an endpoint attack? Propagating a botnet once you have access to the systems. Assuming that we already have access to the systems, we've already passed the most difficult phase. Getting into the system is the most difficult phase. Acquiring a list of ports open to on a targeted computer, very, very simple. Because when you're scanning a computer for open ports, you're basically taking advantage of what that computer is already designed to do, which is to respond to TCP SYN requests. Delivering a phishing email to employees, very, very simple task. Whether it's effective or not is a different story, but not a difficult stage. Acquiring access to an endpoint inside of the network. Yep. Acquiring access, some of these other tools these other items they listed could be methods for doing that, but that is the difficult part. How do I get into the system? Even if it has some vulnerabilities, I still have to figure out how to take advantage of those vulnerabilities. Match the social engineering term with the description. All right. Tailgating, following somebody into an area where a badge is required. Absolutely. Dumpster diving, watching someone enter their credentials, sending an email to entice a user to click a malicious link, or looking for account information in the trash. Oh, that's weird. Why did it do that? Well, that's this one down here. Somehow my little line didn't draw very well there. Let's just do it this way. This would be tailgating, and this would be dumpster diving. All right. Watching someone enter their credentials to compromise them, visual hacking, and then sending an email to entice a user to click a malicious link. That is phishing, without a doubt. All right. If only the questions on the test were this simple. What is the difference between spear phishing and whaling? There is no difference. Both are targeted phishing. They are both targeted phishing. That is true. But there is a big difference. Spear phishing, of course, you're targeting a group of individuals that have kind of a commonality between them. You know, they all work in HR or they all work in the engineering department or whatever. Whereas whaling, you're targeting the CXOs of the organization, or at least somebody that has a superior knowledge about things or more access to things than anybody else would have. Spear phishing focuses on voice services, and whaling is sent through SMS messages. Voice would be vishing, voice phishing, and SMS would be smishing, SMS phishing, but it's actually pronounced smishing. Yeah, that's not that answer. Both are targeted phishing, but only whaling targets individual executive positions. Absolutely. That would be the correct answer there. What portion of the following URI is known as the query? All right. I'm not going to read that whole URI, but the query is whatever happens after the question mark, right? So source equals learning is what we're actually asking. That makes sense, right? Because a question mark is basically a query, if you think about it. So anything that happens after the question mark would be considered the query. What is the purpose of an exploit kit in a client-side attack? It hides an iframe in a legitimate web page to redirect the user to an exploit server. No, that is not it. It beacons to an attacker's command and control server, allowing the attacker to issue commands. No, that's not it either. That would be the CNC communication. It compromises a web server to carry out DDoS attacks as part of a botnet. Negative. It profiles the user's computer, delivers the exploit code to the computer based on its OS. browser and applications, and most critically, based on those vulnerabilities in those applications. That's the most critical piece. So the answer in this case would be D. There we go. What is the main purpose of an exploit kit for malicious actors? Continuously changing the IP address of the command and control infrastructure. Nope. Sending updates and new commands to all endpoint bots in the DDoS subnet. Now that would be the CNC server. Scanning potential victim computers for vulnerable applications so that malware can be delivered. That is absolutely the goal of the malicious code in the exploit kit. That's what we're doing. That's by definition what an exploit kit is. It is intended to be able to identify what those vulnerabilities are, and then based on those vulnerabilities, we're able to install the malware or the payload or whatever it might be. If an attacker, let's go up here, if an attacker uses phishing to obtain user credentials for an employee without administrative access and needs to install a rootkit backdoor that requires system-level access, what might be the attacker's next course of action to gain administrative privileges? Set a scheduled task to install the rootkit the following day under the current user account. Negative. We are trying to install a backdoor, but keep in mind, we are also trying to escalate our privileges. And that's a very, very important concept here. Attempt to extract the local administrator credentials that are stored on the machine. Certainly, if I can get those administrative credentials, then definitely I would have the ability of escalating my privileges. All right. Why would an attacker use Mimikatz once they gained access to a system? I didn't really talk about that too much. I kind of gleaned over that or skipped over that. But to extract passwords and hashes for user accounts that have actually logged into that system. Mimikatz is that's what that tool is designed to do. All right, we have our last question here. What is the function of an exploit kit landing page? Well, the main function is to simply deliver the malware, right? That's the site that's compromised that allows us to scan the host for vulnerabilities and ultimately deliver the malware to that particular client. All right, so we're going to go ahead and wrap up this module. Our next module, describing network security technologies, we're going to start to get into more of the Cisco related stuff, and then we'll get into some ASA and some next generation firewall stuff as well.